So once again, we're looking at rates of change and applied context. It's still, once again, if you ever see a problem and they say, here's the rate is represented by C of t or something like that, then that's telling you derivative. Rate is derivative, right? And so here, if they're giving you the original function, like water's pouring in, and here this represents the volume, find the rate of change of the volume, you're going to find the derivative. So let's read through this. The following function gives the cost in dollars of producing X gallons of wood stain. C of X equals this crazy function. What is the instantaneous rate of change of the cost when 100 gallons are produced? So what do we need to find? We need to find C prime of 100. That's not bad. C of X is 0.0004x cubed. I guess it is bad with all these decimals, right? Let me give myself a little bit more space. Minus 0.001x squared plus 0.1x plus 3200. So that's what represents the cost. So when we take the derivative, which is going to be C prime of X, we're going to get 0.0012x squared minus 0.002x plus 0.1. And we want C prime of 100. So let's plug in the 100. And 100 squared means we're going to have 4 zeros, which means this decimal will move over 4 places. 1, 2, 3, 4. So that'll be 12. And then this one will move over 2 places. 1, 2. So it'll be 0.2, I believe, plus 0.1. I feel like I need to double check this on Desmos real quick. And so 12 minus, it'll be minus 0.1. Would be 11.9. Actually, that makes sense. And it's a rate, so we're going to put dollars per gallon. It's multiple choice and end up there. That's got to be it. Same thing for this one. Let me see. That's the trig one. Do a solution on that one later. So what is the instantaneous rate of change of the volume after 10 minutes? So a tank is being drained. The following function gives the volume in liters of the water remaining in the tank t minutes after the drain is open. So this represents the volume. So V of t is the volume, but what's the rate of change of the volume after 10 minutes? And you got to pay attention. 10 minutes, you know, sometimes like a problem like this, they're saying, what's the temperature at 9 a.m.? They may say hours after 2 a.m. So 9 a.m. would be 7 if it was like hours after 2 a.m., but that's hours after midnight, so it would just be 9. But be careful with that. Make sure you pick the right value of t. So you do want to be careful with it. So with this one, it's pretty straightforward. T is the number of minutes. They're saying after 10 minutes. So we're going to find V prime of 10. So V of t is 3,000. Times 1 minus 0.05 t to the second power. So V prime of t, we bring down that 2, so we get 6,000 times 1 minus 0.05 t to the 1. Then multiply by the derivative of the inside, so that's times negative 0.05. Okay, that's 1/20th would be 0.05, so a 20th of 6,000 would be 300, I believe. Makes sense. Because think about it, half of 6,000, 3,000, and a tenth of that would be 300. So then V prime of 10, I know my dad would be proud of me with my mental math. Usually not so good with mental math. That's what calculators are for. So we get 1 minus 0.5, negative 300 times that. You can already see that's going to be half of 300, which is negative 150. And it makes sense. We would get a negative rate because guess what? If you go back to that problem, remember how it says that it was decreasing? The water in the tank is being drained, so we should have a negative rate. That makes sense. It's decreasing at a rate of negative 150 liters per minute. So that's also another important topic, that if your rate is negative, we're decreasing, which is what we talked about in the last unit or section or whatever it is.